was like that. All right. 1, 2. Buckle my shoe. 3, 4. Sorry. What is it? Is it a frog? What kind of frog is that?
It's a Waffle House frog. See, it's stone.
Oh my gosh.
It's stone.
That is not school.
I saw it's kind of like a I don't know, group therapy or something. Hi, happy birthday.
He doesn't get the tiara because he's sweaty.
Are you still? Yeah, of course. I just didn't want to get up earlier. I'm up now because I'm hyper focused. Can you pick the calculator up? I'm gonna lay that right there. I gotta center it. Wait a minute, it's not centered. Oh, there's. It's well, the air's blowing that way. I don't understand. All right, there you go. All right, let me center it. Oh my gosh. No, pick that up. How long will you let me do this?
Fierce!
Just say.
Sorry,
Before you say that.
I thought you were
All right.
playing the game.
Hey, you're recording. What you listening to? What you listening to? Rock?
How do you sleep with rock?
He likes to get in his car and calm down and yeah. All right, we're looking at 1, 2. We're gonna finish these notes. Yeah. At least it was. Hopefully it was good for you.
That one.
We got to that one, and I said, challenge. Everyone try it right now without looking at the notes that we squeezed in on the last slide to see if we got it right. Yes, some of you quit on me right there, but that's all right. That's all right. But I was asking if you could try it. So remember, getting back into the mindset from yesterday, we are checking whether a function, we're checking the function to see what's the restriction. Is it like a fraction where you can't divide by 0? Is it an even root where you can't take the even root of a negative number? And then you're setting up the problem in order to find what's allowed in the domain. This is an even root. You can't take the even root of a negative number. You should have set the radicand, that's an x, you should have set the radicand greater than or equal to 0, meaning it has to stay positive or 0, and then solve. And that is your domain. You just need to write it in interval notation. If you can't go straight from this to interval notation, then I would encourage you to draw a number line accordingly. So this is saying it stays greater than, it's greater than, or equal to -2, and that's going in the direction of positive infinity. So it would be bracket, because it touches -2. You can plug -2 in there and you would be okay. And comma, infinity. Then parentheses. That's what you should have gotten. All right, and then there's a stop sign. So that's it for the day. And we're gonna psych! Oh, look at that. My fingers were crossed. All right, go to this. Now let's look at when you're visualizing the domain. This is what you just did, but showing you the visual behind it. This is where 2 highlighters might be helpful. I only have the one color, and then I have 1 blue and 1 pink.
I'll take the blue and pink.
That would be like,
I'm joking.
not,
I'm
that's
joking.
not
I'm joking.
spreading the
I'm
wealth.
joking.
Oh.
Borrowing.
Does anyone want? Okay. All right. Alright, does anyone want yellow?
Deal.
Yellow.
I thought mine.
I
Good,
think
you
pink.
know, just chat it, you sure?
Think
Use
yours-
yellow, and if the neighbor I might actually pass some more.
Here's, do you need some encouragement today?
Look at these, look at these.
They can be cut as hollow. They're hard.
Orange,
Look at all these.
Oh. Come on, over.
Here, I need.
Math is bad.
Love you, Callie. Math is good.
So,
Visualizing domain and range. The reason I made you get the highlighters is because I wanted you to see that when you're saying what the domain is, you're visualizing along the x-axis what x values are covered by the graph. So since that is a quadratic opening down, as it's going down, it's also going out in both directions. So every single x value will appear in the t-table if you were to look at the t-table of this function. And then change colors, and the same concept goes with range. The range is what y values would appear in the t-table. And so my question to you is to start training yourself, like turn your head sideways, and then look at the y-axis the same way you just did the domain and the x-axis. So like, is there a y value of 5 anywhere on this graph? No. What is the highest y value possible?
4.
It's 4. And it's coming from negative infinity, and it's stopping at 4. So in terms of that graph right here, switch to pencil. The domain would be all real numbers. And this is written on your paper, but I'm writing it again. And the range would be negative infinity up to 4, and it does include the 4, so you put a bracket. What you need to remember here is when you're reading domain and range, you always read it left to right or bottom to top. Or you could say to yourself, you always read it from negative infinity to positive infinity. And that would, that would encompass both horizontal and vertical. But it's always least to greatest, every time. So if you look here at this domain and range, I'm going to go back to my yellow. So this graph, if I was to collapse it down to the x-axis, it would cover -4 up to 3 with an open circle on 3. It would cover -4 up to 3. Now turn your head sideways and imagine it like an accordion collapsing to the y-axis, and it would cover from 2 up to 5 with an open circle on the 2. So the domain is -4 bracket to 3 parentheses. And the range, now least to greatest, is 2 to 5. Ask me again. Reword it.
I thought the line on that text was like,
Oh yeah, that's just me showing you. If I was to collapse the graph to the x-axis, like what would it include? And that yellow is trying to help you visualize that. All right, so now go to this slide. So the purpose of this slide is using the graph to find the domain and the range of the function. So the slide that we we ended on yesterday was just find the domain. Now it's find the domain and the range. So we're finding both. Before we dive into all of these examples, let's talk about the different scenarios. I'm just throwing this up there. So you have a visual. Okay, if you have linear means a what? A line, right? Domain for linear. Well, it's all real numbers. And then range, all real numbers. So if you have a line that's just a standard line, no holes in it, because if there's a hole, then that changes the domain. But if you have just a traditional line, there's no restrictions. It's all real numbers in both domain and range. If you have a quadratic, and I'm going to put this on the same graph, you would have it either opening what direction? Up or down. So I'm putting them on the same graph so for simplicity. If it's opening up or down, what's the domain? All real numbers. It doesn't matter, right? The domain of every quadratic is all real numbers because as it's going up or down, it's going out. So the domain would be all real numbers. The range would vary, right? If you imagine, like, I'll change colors. So like the range for this one would be here and up. The range for this one would be here and down. Of course, you would write it from least to greatest, but so when you have a quadratic, you've got to watch the range. It changes, right? Depending on where it is, what direction it's opening. Next would be a cubic. A cubic function, in general, looks like that. All real numbers for domain, all real numbers for range. It's going opposite directions. It's also going out. To the fourth degree. Or to what degree? Where do you think has a pattern of whatever I say with the fourth? Yes, 6 or 8. What's the pattern? Even exponent. Even exponent, right? What about, let's see, that was third. 5th degree. What do you think I'm going to say? 7th. 9th. Odd exponent. The overall pattern, if it's an even exponent or if it's an odd exponent, the domain is the same. What is it? For even or odd? Domain. What? All real numbers. Every polynomial function, doesn't matter the exponent, if it's 2, 3, 4, 5, 6, 12, 15, 22. Every polynomial function's domain is all real numbers, and that's because the polynomial keeps going, right? Now, the range could be different. The range matters in which one? Even or odd? In the evens. And here's your baseline. Here's how you remember the pattern I'm showing you. Everybody's familiar with a quadratic. Everybody knows what it looks like. And everybody should know what a cubic looks like. So if it's an even power, you've got to watch. What is wrong with me? Watch, oh, it's probably because I just turned 50 last week. Watch the range. Watch the range. If it's an odd power, odd exponent, do I need to watch the range? Because it's going in opposite directions, right? Look right here. So the domain and the range are both all real numbers when it's an odd exponent. So that's a pattern. If you can commit that to memory and understand it, it saves you frustration when I throw a new problem at you. Because you can say to yourself, okay, if it's a polynomial, I just need to know if it's an even power or an odd power, and then I know what to check. Now, we didn't talk about if it's a rational or an even root. We didn't talk about roots. So if it's rational, rational means it's a fraction. So for example, 1 over x. That's a rational function. If it's rational, you have to check the denominator to see what's not allowed in the domain. We did this yesterday. We didn't say rational. We said if it's a fraction. So you check the denominator for the domain. If it's an even root, you set the radicand greater than or equal to 0 for the domain, and then you do need to graph it in your calculator to check the range. Okay? Alright, so I wanted to show you all of that before we actually did the practice problems. So now we're going to do the practice problems. So I'm going to go back. If you need this to write down later, I'll come back to it. I'll leave it there. Let's go to this. So the directions say find the domain and the range of each. You might want your graphing calculator because it will help. Look at A. What type of function is A? How do you know it's linear? It's y equals mx to the first power plus b, right? When it's y equals mx plus b, then it's linear. And if it's linear, then it's what did we say is the answer every time?
All real numbers.
All real numbers. Unless, of course, unless it's that horizontal line, which is a special case scenario. All right, so what's the domain? What's the range? All reals. Because that's linear. It's an odd exponent. B, what did we say yesterday? Can't be negative. We said take the radicand and set it greater than or equal to 0 and solve. So we got x plus 4 has to stay greater than or equal to 0. Now that's just your domain. To get your range, you need to graph it and look at it on the calculator. Let me pull mine up. So my domain, if I need that number line visual, I can see with plot on -4, closed circle, and it's going in the direction of positive infinity. Now I'm going to figure out the range by graphing it in here. To graph it in your calculator, this one's square root, so this one you already know. I was thinking of absolute value. Square root x plus 4. Zoom 6. Now turn your head sideways and ask yourself what y values are covered. So that's right here, and it's going to positive infinity. Do you see that? Now the question is it bracket or parentheses on the 0 that's right here? This right here. Well, what did we say happens if you plug -4 in? If you plug -4 in, you end up with -4 plus 4 is 0. What's the square root of 0? So is that a point on the graph? Yes, because you came to an answer, which means it's a bracket on the 0. You're saying that if you plug in -4, you get 0. What will a cubic be? For which ones? Trust yourself.
All real numbers.
For which one?
Both.
Both. I was looking for you to say both. So this is cubic. It's to the third power. We talked about how the odd powers, polynomials, are all real numbers. You should never get those wrong. You can always graph it to see the visual. All right, what about D? D is, can't have a zero in the bottom. It's a fraction. This is rational. It's called a rational function. So we say to ourselves, okay, the denominator cannot equal 0. So we're going to set it equal to 0 and solve to see what's actually off limits. 2 is off limits. So the entire number line's allowed except 2. If you need the visual, draw it, but you need, or you could say to yourself, okay, so the whole number line's shaded, but I have a circle on 2, which means I'm hopping over 2. So my domain is from negative infinity to 2, skip over it, and go to infinity. I did. Oh, because if I put 2 in there, what would I get on the bottom? And 0 is a number, but can 0 be in the bottom of a fraction? That's the problem. The difference is up here when we had the square root, you can have the square root of 0. That's allowed. 0 in the bottom is not allowed. That's what changes it from being a bracket to needing to be a parentheses. Also, if you put bracket here, you would be writing a redundant interval. Because you're saying, if you had a bracket, you're saying you can go from negative infinity to 2, and you can use 2, but then skip over 2, use 2, you know what I mean?
Yeah.
So if you accidentally forget that, then look at it, and maybe that'll be like triggered, that something's redundant. In terms of seeing the range, go to graph it. So we've got, now I want you to embrace the math print fraction shortcut. Alpha, y equals, that menu pops up. The top one is telling you the fraction math print option. And I love it because you can actually see the fraction going in the calculator and you can make it match yours. X minus 2. And then I'm going to hit zoom 6. Now we already did the domain. We're looking at the range, which means turn your head sideways and imagine, ask yourself, clearly there's a lot of stuff going on here. What's it not including? It's not touching 0. It's approaching it, but it's not touching it. You'll notice there's stuff here, here, and then all of a sudden, it's really hard to tell because you might argue, well, it's touching it. But if you zoomed in, remember we talked about how there's infinite numbers between any two. So even if you zoom in, if you just keep zooming and zooming and zooming, you're never going to see it touch. You know what I mean? Like, it's always finding that next number just before it hits 0. So we would say that the domain, or the range, where are we? We would say that the range is skipping over 0. What do you think E would be? Domain.
All real numbers.
So this is to the 4th power, which means it's a quartic.
Whoa.
Oh, I forgot those were there. Are they there the whole time? No, just that one.
You're writing dots everywhere.
It's all right.
It happens when you get old.
Really hate you.
That would be good. That was
Better watch out when you leave. That door might hit you. Or the good Lord split you. What? I don't hate you. But you gotta quit calling me old, man.
It's either me or him. They hate one of us.
Brody. Brody's the name. It is a quartic, which means it's a polynomial. However, this is an even degree, which means you need to watch out. Think of it as a red flag. Be careful. Don't just run with all real numbers. The domain is all real numbers, yes, but the range is not. Hold on, we're spazzing out over here. I'm just gonna write over it. So you would go to your calculator, you would graph it in y equals, and then you would just look at the graph. Let's see. X to the fourth minus 2x squared minus 3. And I'm going to zoom 6 it. And then we're going to run with what it looks like it's hitting. We're not going to worry about trying to actually zoom in. And
-3.
so this is, whoa. Do you see it? Get there. Something's wrong. There it is.
-4.
Okay.
Sorry.
So -1, 2, 3, right here looks like where it's actually starting its lowest y value and then it's going towards infinity, right? So it'd be -4 to infinity. Yeah, so it is a polynomial, which means you don't have any rules. So it's safe to say that whatever it like is starting out or running to, it's touching because it's a polynomial. So -4 to infinity. All right, so look at this last one. This is a humdinger. Humdinger. Those are the words we used back in my day, you know, 50 years ago, 60. Yeah. No, y'all never played Cranium?
Yes.
What is
Cranium
that?
is a board game, and there was something called Humdinger, where you draw the card and you have to hum the song, and your team has to guess what song you're humming.
No.
It's surprising that every song sounds the same if you have to hum it, pretty much. So anyways, this is a humdinger right here. At least don't hum phones. If you look right here, I gotta get rid of those dots. This is what type of function? It is a what root? Square root, even root, which means we gotta be careful, right?
Right.
The radicand cannot be negative. It's okay. It's very common to mix those up. Just remember, fraction can't be 0 on the bottom. Radicand can't be negative. So we're going to take the radicand, as ugly as it is, and we're going to set it greater than or equal to 0.
That's
Now there's a lot to do here, so here's a nice little Algebra 2 flex moment for you. I want you to, oh that's a 3. I want you to clean up this binomial that's being squared. Clean it up. Get it down to a polynomial in simplest form for me.
what that is.
You want to simplify?
Sorry.
It will factor.
Where we
Sure.
at?
So we're going to clean this up. You should multiply it out. You have binomial times binomial. Don't you dare write x squared plus 9 and be done with it. That is not correct. There is a term in the middle. Then you do have that 4 there that is going to merge with that constant. You also have that negative in there. Yeah, this This is a really good problem. I love it. So looking at it, did you come to that? Okay. I'm going to distribute the negative, and I'm also going to move the positive 4 to the end. Or maybe I won't, because that might throw you off. All right, so I'm just going to distribute the negative. 4 minus 9, right? All right, now we got some middle school stuff coming up right here that hasn't happened in a while. You have a leading term that's negative. You can't factor the polynomial with your leading term being negative. I mean, you can, but it's what's the word? It's not proper etiquette, I guess you could say. The proper etiquette is to get the leading term positive. So I would do what with the entire thing?
Divided by 1, negative 1.
I can either divide by -1, or the beauty of -1 is I could multiply by -1, right? And it's the same concept as dividing by -1. But you've got to remember right here that this is not an equation, it's an inequality, so technically it needs to stay, or it needs to flip. So I'm going to multiply the whole thing by -1 on both sides. And then I'm going to, in orange, draw my new inequality sign since it looks different so that you recognize what changed. Now, how many of these are going to actually be on your test? Probably none, but it's good exercise. So now look at it. This is good algebra 2 practice. Will this factor?
Yes.
Yep. A is 1, factors of 5 that add up to -6. I'm doing that shortcut where you write AX and AX because I want you to see that just because A is 1 doesn't mean run to parentheses. You still need to do the shortcut, write the A, and recognize when to reduce or not reduce. It's -5 and -1. Now, pulling the zeros out of this, the solutions, what would make this fraction 0 if x were 5? What would make the fraction 0 here? If x was 1, right? X, yes. So what we're saying here is that these are what's called critical values. Now what might be helpful here is, since this was so ugly, go to your calculator now and look at the graph so you can put the puzzle pieces together. Square root 4 minus parentheses x minus 3 close parentheses squared. Zoom 6. I'm going to zoom in. Zoom in, and I'm going to move it over. Isn't it cute? I'm going to move it over here.
There's a right
All right. So looking at this, what x values are zoomed in so far? I can't even tell what that is, but we know what critical values we came up with, right? So it's running between what and what? It's running between 1 and 5. Now, if we plug 1 in here, let's check it. If we plug 1 in, or you can go to your table, let's just do that. Second table. If I plug 1 in, do I get an answer? Yes. If I plug 5 in, do I get an answer?
Yeah.
Yes. Do you notice a maximum y value? We know that it's 0. Do you notice how the maximum y value is 2? If you go to the graph, you confirm that it's not going above 2, and the table just didn't include it. Do you notice how this tick mark 2 is right here? So this one is kind of like this is like a challenge question. So we found the domain numbers, and then we confirmed it on the graph that it's running from 1 to 5, and it's okay to plug 1 and 5 in. You get decent numbers that are allowed. Then we looked at the graph and noticed that it's going from 0 to 2 on the y-axis. So there's our domain and range. So I'm going to write it above it. Domain, 1 to 5. Range, 0 to 2. And then you'll be happy to know the very next slide, which although it is a word problem, is showing you how evaluating functions would appear as a word problem. So if I throw a word problem at you like this, and I say to you, here's a function that represents in Celsius the degrees from the winter to summer given by this, where T is the temperature change. The first tip for word problems is if I throw a function at you like this, I want you to box it in and just tell yourself, okay, there's my equation. I don't want you to necessarily try to wrap your mind around it because I'm not asking you where they came up with 0.000013 times 1420 times t. I don't care where it came from. They're giving it to you. You just need to know, okay, the function is L, the input is T, T is temperature, L is linear expansion of the bridge. If you've ever been on the top floor of the mall, or if you've ever been in the media center here, or if you've ever been on a bridge, sitting in traffic or walking, you will feel it move. It's actually really cool. There's a fact, I can't remember. How many degrees does the San Francisco Bridge sway?
13.
Is it really?
No. Oh no.
The Golden Gate Bridge can move up and down as much as 16 feet. Because if it does not move or bend, it will break, right? That's like a saying in science. If it does not bend, it's going to break. It's got to have some flexibility for those winds and storms. So this is a suspension bridge. They're telling you here's the function that it flexibly moves based on the temperature change. Find the linear expansion. Well, what letter was that? L. That is saying find L. If I'm telling you to find L, then I'm secretly giving you what to plug in. What letter?
Remember the T.
T. Every time. Every time. So find L when T is, and then they give you the list. When T is 30, 42, 50, 56. Well, you could sit here and type it in your calculator over and over and over, or you could type it in y equals and go to table and just turn it on ask. Remember that? Where you're evaluating, or you can go to your graph. I have 3 minutes. I'm going to show it to you. So you can go to y equals, it's 1, 2, 3, 4, 1, 3 times 1420 times t. Don't worry about it being an x. Then I'm going to go to zoom. Now that's a really ugly function, so I'm going to go zoom fit. And I still can't even see the whole thing. Now I'm going to tell the calculator, tell me the values. That would be second calc. The very first option is value. This is where you can tell it to actually evaluate it. So hit enter, it's gonna say, what do you want me to plug in? What was the first one? 30? You're gonna plug in 30.
Miss Holcombe, I don't believe you can do that.
Well, mine worked. Let me go to the table. Let me change it to 30. Table start 30. And then I'm gonna change it to ask. Really annoyed. 30.
It was 0.5538.
My favorite graph.
I will figure out why that's not working, but you should get 0.5538, and it was measured in
To
meters.
finish this piece of paper,
Huh?
to finish these 3 questions, is that our homework?
No, your homework's 1, 2.
Oh, already finished that.
Then you're being good. The next slide was simply like wrapping it up if you needed it. There was nothing to discuss.
Yes, ma'am. Let's go, bud.
I'm so confused.
She actually have that.